Alrighty, once again, Math Geniuses, and we're off and rolling. We got Unit 5, Lesson 8 this time, and this is the final one of Unit 5. Getting ready for a test here soon. This one's on word problems with systems of inequality. So bottom line is, can you solve word problems with systems of inequalities? And that's what we're going to accomplish in this section. So let's get to question 1. Alright, these are real life world problems out there that we can use. In this case here, it says John mows yards on his father's landscaping for $10 an hour, but he also works at a bakery for $15 an hour. He can work at most 52 hours during the week and in the summertime. He needs to make at least $600 per week to cover his cost of living expenses. So you got a lot of key things here. At his landscaping business, he gets $10 per hour. At the bakery, he gets $15 per hour. He can work at most, okay, that's the key here, at most 52 hours in the summer, and he needs to make at least $600 per week, okay? All those are key pieces here. Well, in part A, it says if John works 14 hours mowing, okay, and 30 hours at the bakery, does this satisfy all the constraints, okay? Well, you got two parts here. First of all, 14 hours on the one, plus 30 hours on the other equals a grand total of 44 hours. Is that at most 52 hours? Yes, you should remember that 52 hours at most means that amount or less. So that part, A-okay. The second part, though, is the money. He's going to do 14 hours mowing. Well, that's 14 hours times, how much does he get mowing? You got to go back up the top here, and it's $10 on the landscaping. So if I multiply 14 times 10, I get 140 bucks. And the other job, he is working, it said 30 hours here at the bakery. So you got to do 30 times, and that up above said $15 an hour. So if I multiply that, I get 450. And now if I add the two together, so 450 plus 140. Let's see how much money he made. Wouldn't you guys like to make this amount, huh? That wouldn't be bad. $590. Did that make the quota of what it said at making at least? It said at least $600. And no, the bottom line is no, he is short 10 bucks. Okay? So no, it didn't work there. All right? All right, part B here says, if X represents the hours John spent mowing, and Y is the hours spent at the bakery, write a systems of equations. Well, here we go. This is not that hard. What did I do in the first part over here? I took the hours at the bakery or mowing and the hours of that to get a total. So here we go. I would take the hours at the mowing, that's X, plus the hours at the bakery, Y, and we said that had to be at most, so it has to be less than or equal to 52 hours. Okay? Then you have the other part. You know that you get $10 at mowing, so we're getting used to these here. So that's $10 times every hour mowing, that's your X, plus $15 times every hour at the bakery, that's Y. And that has to be at least, which means that amount or more, of $600. And that's all I did. I took the things there. It's kind of like what we just did here over on the other side where we just threw the numbers in. And now I put the X's and the Y's with them. It would be probably nice to put let statements here, let X equal, but they kind of said it in the question, so I didn't write it down. Those are my two systems equations. Now let's see what we got to do with them. All right, in part C it says John must work a minimum of 10 hours for his father. Will he be able to make enough money to cover his living expenses, and show the work down below? So if you take a look at it, John's dad is the mowing thing, so he does 10 hours, a minimum. So I'm going to go with the minimum because that pays the least. Times $10 an hour, that's 100 bucks. Okay, so that's the piece that he's got to work a minimum. He can make more than that from there, but you got to look at the other part. He's allowed 52 hours. Well, if I take 52 hours and I subtract off 10 hours he's working for Dad, you're down to 42 hours, aren't you? Okay. Well, 42 hours then times 15 bucks an hour, okay, gives you a grand total of 630. All right. He's going to make, if he does 10 hours, he makes that amount from Dad. He already made 630 then the other way. So clearly this already beats the minimum of 630. So yes, no problem. How much more can he work than 10 hours for Dad? Well, that's the big question we're going to get into, and that's in the coming parts. All right, now they want us to graph those systems equations. So I've written the two equations from part B off to the side here, neither of which is in y equals format here. And actually, I got to fix something. We need to put equal to bars, I believe, under both. So I'm going to put a little equal to bar, whoops, under this one here, and an equal to bar under this one right here. Okay, so on this one right here, I would move the x to this side, other side, and you will end up with y less than or equal to negative x plus 52. Okay, and this one right here, after you do your magic, I'm not going to sit there and show you all the steps, but you will get y is greater than or equal to negative 2/3 x, okay, and it's going to be plus 40 when you do all the reducing and everything. So those are our two equations, all right? Well, we're going to graph them. So if I take a look at the first one here, and I actually plug things in, I actually get, I'm going to actually set this up. So the hours of mowing here, and I'm going to go with this. I'm going to go by 10. So this will be 10, 20, 30, 40, 50, 60, etc. So I'm looking at my hours mowing. Remember, he can go up to 52 hours. So that covers me if I go by 10s, kind of like that way. And the other one was, well, talking about hours at the baker, you could go the same way. So you can go up by 10, make each one more 10, 20, 30, 40, 50, up to 60. We can really only go up to 52. So that's hours at the bakery. So bottom line is if I plug these things in here and I do the points on the first one right here, and I'm looking at this equation right here, if I actually do 0 hours of mowing, that means I'm right here on the y-axis here, I actually would be up at 52. So I would put a point somewhere up here. Oops, we're going to undo whatever that line was that we just did. All right, so I would actually have a point somewhere up here about at 52. And if I figure things out and I keep going on that one, I think you can actually go out beyond 60 if you actually do the calculations. And he will have a line that looks something like this out here, okay? And so he can be that amount or less, so I can actually shade this way, okay? I'm going to pick a different color for the other one, and let's use green for this equation. On the y, if I'm at 0 down here, he can actually go out to 40, so we have a point right there at 40. And if I figure that one out the other way, he can go all the way up to something a little beyond that, I believe, again. You can get the points right off your calculator, okay? A solid line there, and that is also, that one actually is going to be greater than. I'm taking a look here if I shaded them right here, and that's going to be above. Oops, I did the one the wrong way. I don't know if I did the other one the other way. All right, and the two are going to cross in there somewhere. Once again, you can do a better graph on your graphing calculator than that, but then you get your super solution out there as far as the pieces go. And the first one, yeah, that was less than the line in that. So we got a super solution in here, all the various pieces. Okay, well, part E here now says for John, he says, going and taking a look at it, John's father wants him to work a lot of landscaping. Show at what point does the graph is the greatest number of hours. Well, guys, that's where it's going to intersect. So that's going to be that intersection point. And all they ask you to do is point it out on the graph. They didn't actually ask you to calculate it. We could do that on the calculator. We'll show you how to do that in class as well. But that's all you're doing. You're graphing the two, shading, and see where your different solutions are. Now we got one more part F. Now in part F, they want you to algebraically show the greatest number of hours that John can work at his father and still cover his expenses. And once I said on that graph there, in part E, it's where the two meet. So bottom line is where those two equations are going to meet. So you got to take the one where you got the negative x, okay, plus 52, because remember you have y is less than or equal to that. And you got to set that equal to that point. The other one, where the y part was that negative 2/3 x, okay, and it was plus 40. Now remember, you can also do this on the graphing calculator and go take a look at the table to see if it come out an exact point or not, and it will come out. You're going to check it. And I would use that as a check right now, just to do a little practice here. Well, bottom line here is, it depends which way you want to look at this. I'm going to move the x to the other side. I'm going to solve, so that's plus x here. And so I've got a 52 now is equal to negative 2/3 off of x, remember, that's a 1x. So that's really 3/3 is 1/3 x. Okay. And then I got plus 40. From there, it should be pretty easy for you guys. Move the 40 to the other side. I get 12 is equal to 1/3 x. And you got to remember, how do I get rid of that 1/3? Yeah, you divide by 1/3, or you multiply by the reciprocal, 3 over 1. So my answer when I do 3 times 12 is 36 hours. Okay, that's what x is equal to, because these 3's are going to cancel. Okay, that's where the two end up equaling. And if you go into your graph and you look at your table, and you go down to 36 hours for x, you will notice the two y columns, you put the one equation in the other, will be identical. And that's our answer, okay? Make sure we show you that in class, though, as well, so you got it. But that's our answer, okay? Moving on to one other question. All right, in exercise number 2, we're going to write a system of equations. We are not going to solve them. All they want us to do is get some practice writing them, okay? So it starts off saying Frank is putting together a bouquet of roses and daisies. He wants at least one rose. So there's the first thing we need to know about. At least one rose. So if I end up letting R equal the number of roses, so let R equal number roses. Okay. My first thing I'm going to deal with here then is R has to be at least one rose. And you guys should remember that R has to be at least means that amount or more, even though I know you see the less than, at least sounds like less than, it's not. So R has to be greater than or equal to 1. There's one equation already set for you. Then it says you need at least 2 more daisies than roses. So on my daisies, if I'm going to deal with that, I'll let D equal the number of daisies. All right, and if I need to have, it said at least, once again, 2 more daisies than roses, then what I need to have is daisies has to be greater than or equal to, for that at least again, 2 more roses, let's see here, daisies than roses, so I need the roses, plus I need 2 more than that, and more than, remember, means to add 2. So that's our next equation. Finally, then it says roses cost $4 each, and daisies cost $2 each, and Frank must spend $40 or less. That's the key. So we know normally we say, oh, okay, so roses plus daisies has to be $40 or less, so that means so you can equal it or less, $40, but you got to deal with, because they didn't tell us the number of them, the cost. So $4 for every rose, put a 4 times every rose, and you've got $2 for every daisy, and there you go. Here are your 3 equations. All right, let's look at B now. All right, B says a diet company is attempting to create a non-carb brownie composed entirely of fat and protein. The brownie must weigh at least 10 grams, let's see here, brownie must weigh at least 10 grams, okay, and have no more than 100 calories. Fat, they tell you, is 9 calories, so fat is 9 calories per gram, and protein is 4 calories per gram. If X is the weight, okay, in protein, and Y is the weight in gram, write a system of equations. So, they already told us what X was equal to and Y was equal to. So the bottom line here is, if you go back to the first one, it says the brownie must weigh at least, and that's the key, 10 grams. So if you take your weight, which is X for the protein, and your weight in grams, together, the two of them must be at least 10 grams. So at least, once again, means that amount or more. That's your one equation. It's that easy. The other part they said, though, is, but it has no more than 100 calories. Well, the calories was figured out, we said 9 per gram of protein and 4 per gram of fat. So you're doing the same type of thing here. You're going to deal with X plus Y again, and it can be no more than 100, so less than or equal to 100. And we're going to turn around, and you know that the one part, 9 for the grams of fat, which is your Y, goes there, and your 4 goes with your X, and you've done it. Once again, we've written the system of equations. I want you to try example 3. We're going to check it out in class tomorrow night. Write a nice WSQ, but all you're doing is translating stuff, write your equations, and away we go. All right, have a good evening.